Strings are a fundamental data type, and they're extremely useful because not everything that we do in programming has to do with numbers. People's names, addresses, even phone numbers sometimes are used as strings. To review just quickly, a string is any alphanumeric character, and by alphanumeric I mean alpha meaning it could be a letter or a special symbol, and numeric, of course, meaning that it can actually be a number. But it's important to remember that numbers that are strings are not the same as numbers. So for example, if I say street number, and I type this in, and I set that equal to 100, street number will be of type int, because you'll notice that that is a whole number. But if we put quotes around it, either single quotes or double quotes, it doesn't matter, street number will now be a string, which makes it very, very different because that means we no longer can use it in any kind of mathematical calculation. Now that's a fundamental difference, and it's important before we move on that you understand that, because strings cannot ever be used in mathematical calculations. Now we can convert a string to a number, of course, and do something like this, and that would of course turn it into street number would then be an integer. Now let's take it in a more practical situation. Let's suppose, for example, on line 1 that we prompt the user to enter something, and we say enter something, will you? Now by default in line 1 we're using the input statement. The input statement returns a string by default. Now what that means is if we don't do anything with the input statement, response will automatically become a string. So let me take a look. Let's actually run this. Run it. You'll see here at the bottom, and let me enter a number. I'll enter 1795 and one number, not 1796, and I hit return. And you'll notice in line 3 I print the type. You'll notice that the type here is str, which indicates that it's a string. That's because unless we do anything else, input will return a string. Now that means the response here cannot be used in any kind of mathematical calculation. However, I can, as I illustrated earlier, I can convert the input and then run it. And let's run, enter something, will you? Let's enter our 100 again. And you'll notice this time it comes back as class int. That's because, again, we've converted it to an integer. In this situation, I could use response in a mathematical calculation. Similarly, I can convert this to a float. And if I run this again, if I enter 100 again, you'll notice there's a slight difference here. It's a class float, and the slight difference, if I printed this, it would be 100.0, not 100. The 0.0 indicates that 100.0 is a float, not an integer. So if I printed response, you would see that it's 100.0, not just 100. Now that's very important, and we're going to do a lot of type conversions over the course of this semester. A string can also be indexed. So let's try this. I'm going to remove the comment here so you can we can print this out. Now this is a confusing aspect of strings. Let me just remove that type statement here. I can index this, but the number 1 index you would think would be the first character of what I enter. But most computer programming languages start their indexing with the number 0, not the number 1. If you printed response sub 1 here, it would print the second character, not the first. Now let me remove my float here so we're dealing with just strings. And let's try this again. Let me go ahead and run it. Enter something, will you? Let's say Main Street, and I hit return. And you'll notice that it prints the type, which again is a string, but you'll notice that the letter that is printed is not the capital letter M, but it's the letter A. And again, that is because indexes start with 0, not 1. I can illustrate this point by changing this to 0. Let's run this again. Let's enter my name. And you'll notice that with an index of 0, you'll see the first letter of my name, which is M. All right, now I hope that helps so far. And we're going to cover one more thing on this particular slide, and that is the idea of what's called immutability. Immutability simply means that once a string is declared, it cannot be changed. Now, if you have a string, in this case we have response, and we want to actually try to change response, we cannot change response. Response sub 0 cannot be on the left side of an equal sign. If you try to do this to change the first letter, remember the index starts with 0, to try to change the first letter, you cannot do it this way. You will get an error trying to change an existing string. So let's go ahead and try this. If I run this, it says enter something, will you? Let's say, since we're going to change it to a W, let's change it to just main, and I hit return. You'll notice I get an error, and it says, in effect, string object does not support item assignment. What that means is you cannot actually change a string in this way. Now, in a little bit, when we get to looping, we'll talk about different ways to do this. But for now, just take my word for it. You cannot actually change strings once they are declared. Now, what you can do, however, is you can do what's called concatenate. Concatenate means to stick things together. So if I have a name here and I want to print the name, again, this would print the first letter, which is the letter J, because the first letter in James Bond is the letter J. But I can also concatenate strings by sticking them together. If I set the last name to be Bond and the first name to be James, I can print out James, comma, Bond by executing the line in line 8. What will happen is that it will stick together the last name, which is Bond, then the string, comma, with a space, and then the first name, which is, of course, James. And if I run this, you'll notice that the letter J prints, which is the first letter, as we said, then the person's name, Bond, comma, James. That's the idea of concatenation. Now, for concatenation to work, the plus symbol will work, but on the operands on either side of the plus symbol must be strings. This is important. If you want to concatenate, for example, a street name and a street number, you cannot do that unless street number is also a string. If you say, for example, and you want to print, for example, a street, let's say 100 plus Main Street, say 100 Main Street, this will not work. And the reason is Python does not know what you want to do. On the left side of the plus sign is a numeric value, that is an integer, 100. On the right side of the plus symbol is a string. So Python doesn't know, do you want to add them mathematically together or do you want to concatenate them? It's not clear. And so Python, to save you, will actually throw an error. If you want to concatenate a number and a string, you must make the number a string literal by putting quotes around it. Then it will actually work, and then there will be no error. Python comes with a wide variety, a rich library of string methods, which can be extremely useful. So in line 4, I declare a name, which is Benjamin Hawkeye Pierce. And then what I want to do is I want to print, let's say, the length of the name. It's a lot of characters there. I can use this function called len, which is short, of course, for length, and it'll tell me how long that string is. In line 10, I can prompt the user to enter a letter, and I can count the number of letters of a specific letter by using the count function in line 11. So in line 10, if I entered, for example, the letter E, it would go through, calculate the number of E's in Benjamin Hawkeye Pierce, and then would print out that result, tell us how many E's there are. So that can be very useful. In line 16, I print the uppercase version of the string. That would be Benjamin Hawkeye Pierce. And in 17, I would print the lowercase version of Benjamin Hawkeye Pierce. Again, very useful, and there are situations where that can be very helpful. And then the last thing, on line 19, I use the replace function. It's also a really cool function. What it will do is it'll take the name and replace the letter E with the letter X, and then create a new string. And when I print that out, you'll see that all of the E's have been replaced with X's. So let's go ahead and run this, and you'll see the result. You'll notice the string length is 23. Now it asks me to enter a letter, let's say E. It will then tell me that the letter E occurs 5 times in Benjamin Hawkeye Pierce. The uppercase version is listed there. The lowercase version is listed here. And then I explicitly told it to replace the letter E's with the letter X's, and you see that as well. So as you can see, there's a number of very useful functions, and being familiar with how to use strings is an important part of your Python knowledge. We will, of course, cover more details in class.